work with Kendriya Vidyalaya, we have an MOU with Navodaya Vidyalaya. So, that is the way we, and of course, social media and other means also.
Nice.
I think we will start in another minute.
Yeah,
Deepakji, please inform us.
Yes, I will inform.
Science series. Many of us are aware of the CSIR-JIGAYASA program as a national level program having sole objective to extend classroom learning and to inculcate scientific temper among school students. In 2020, CSIR signed a letter of intent with Untitled Innovation Mission, which established a connectivity between Untitled Tinkering Lab and CSIR-JIGAYASA program. And as a part of this joint venture of JIGAYASA and Untitled Tinkering Lab, a webinar series was launched earlier, having 15 webinars during June till September 2020, with a focus to overcome the myths in common public, specifically among students, on COVID-19. The present webinar series is a restart of the program, positioned as Demystify Science Series to be a part of CSIR and Niti Aayog's participation in Azadi Ka Amrit Mahotsav initiative of the nation. As from the name itself, this webinar series is a public outreach activity expected to demystify various myths and provide a scientific perspective to students, enabling them to understand nature better and become a responsible citizen. The first talk in this web series was delivered by Dr. Shekhar C. Mande, DG CSIR and Secretary DSIR. And today we are connected for the second talk in this series, and the speaker for today's talk is Dr. Anil Bhardwaj, Director, Physical Research Laboratory, Ahmedabad. We are also connected today with Dr. Geetavani Rayasam, Head of the Science Communication and Dissemination Directorate at CSIR Headquarters. Welcome you both for the webinar today. And I request now Dr. Geetavani to kindly deliver the opening remarks, informing us more about this JIGAYASA program and also welcoming our speaker and the participants. Over to you, ma'am.
Yeah, thank you, Shika, for those lovely introduction about the JIGAYASA. You really covered the aspect very well. So just to give some of the viewers who may have joined for the first time. So our CSR has been reaching out to the students from very early on. In fact, the foundation day of CSIR was always an open day wherein students could walk in and see the activities. That has just been going on for several years. But in 2016, I think Honorable PM said that he expected scientists to take up scientific social responsibility, like what he mentioned, coined that term. And he said that more and more should be done wherein science reaches the masses. That's been the objective. So with that in mind, CSIR actually took up in a project mode this JIGAYASA as a much more intensive activity, which is not just focused on Foundation Day, but throughout the year. Wherein students can engage with the CSR scientists. It could be a one-day visit, it could be a short internship, it could be 2 months activity, and that's been going on at all the CSIR labs. 37 CSIR labs across country are very actively engaged in this JIGAYASA program. And in fact, we had a formal MOU and kickoff of this in 2017 when an MOU was signed with the Kendriya Vidyalaya Sangathan in presence of the Honorable Human Resource Development Minister and Minister of Science and Technology. Ever since then, there's been no looking back, and more than 3 to 4 lakh students have actually taken benefit from this activity of JIGAYASA. And as you mentioned, even during COVID-19 pandemic, although physical activity was not feasible, we moved into the online mode and did this webinars. And an interesting aspect is in 2020, when Honorable PM as the chair of CSIR Society, he reviewed JIGAYASA and he said that, okay, we should also reach to the remotest corners of the country. Not everybody has the luxury of visiting CSIR lab. So is there a way we can devise a way where even remote students can access CSIR labs? And we are glad to say that he's thought of something called as virtual labs, where through an app or a game, we can simulate an experiment and have a feeling of the lab. And to an update, yesterday we just launched the CSIR Virtual Lab at the hands of the Honorable Minister, Dr. Jitendra Singh. And so in a pilot mode, this virtual lab has been launched yesterday, which has games and apps, so to make science more engaging to the students, and we can access it from anywhere they are in India. So that's the outlook of the future. That is the futuristic way of Jigyasa version 2. And as you rightly said, apart from that, we have also launched this Demystify Science series. And the thought behind this is to showcase Indian science, not only CSIR, but overall Indian science, how it is helping the country be Atmanirbhar, right from the space to the energy, or in many areas. And we are very glad that we have Dr. Anil Bhardwaj, who is a leading scientist in the area of planetary missions. And this is an area where CSR hasn't really focused on. And this is an opportunity for students associated with CSIR to hear from the leader in this field, who's been associated with various space missions like Chandrayaan and Mars mission. And thank you so much, Dr. Bhardwaj, for accepting our invite and being here with us. Now I request Shika to formally welcome him with his biography. Over to you, Shika. Thank you.
Thank you so much, ma'am. So this is for the students who are connected. You may post your questions from the lecture in the chat boxes, and we shall be taking those questions at the end during the discussion with Dr. Anil Bhardwaj. So before we start with the lecture, I shall take few minutes to briefly introduce Dr. Bhardwaj to our audience. Dr. Anil Bhardwaj holds a PhD from Indian Institute of Technology, Banaras Hindu University. He joined Indian Space Research Organization ISRO in 1993 at the Space Physics Laboratory SPL of the Vikram Sarabhai Space Center, very commonly known as VSSC in Trivandrum, and was subsequently the director of SPL VSCC during VSSC during 2014 till 2017. Dr. Bhardwaj initiated research in planetary sciences at SPL and contributed to the planning of planetary missions of India in ISRO. He was the principal investigator of SARA experiment on the first Indian lunar mission Chandrayaan-1. He is the PI of Benka experiment on the Indian Mars orbital mission, and his team have PI-led experiments on Chandrayaan-2 and Chandrayaan-3 lunar missions of India, as well as on the Aditya L1 mission. His primary research field in planetary and space sciences, including solar system X-ray astronomy and theoretical modeling of emissions and photochemistry in planetary upper atmosphere and ionospheres and comets, and also on solar system exploration. Dr. Bhardwaj has used space-based telescopes, Chandra and XMM Newton and Hubble, and also the ground-based telescopes, Indian Giant Meter Wave Radio Telescope. He has published more than 160 peer-reviewed research papers in international journals and also authored several book chapters, including a chapter in Encyclopedia of the Solar System, and has supervised many research fellows and students. Professor Bhardwaj is an elected member of all 3 national academies in India and has received recognition at both national and international level. He has received the prestigious Shanti Swarup Bhatnagar Prize in Planetary Sciences in 2007 and the Infosys Prize in Physical Sciences in 2016, and is a recipient of Distinguished Alumnus Award of IIT BHU in 2015. INSA Venu Bapu Memorial International Award of 2016, Decennial Award of Indian Geophysical Union 2017, and also the Professor MGK Menon Award of NASI in 2021. In fact, ISRO has honored him with their highest award of Outstanding Achievement Award in 2017. He is an elected academician of International Academy of Astronautics 2018 and a member of International Astronomical Union, and is currently the J.C. Bose National Fellow. So today, Professor Bhardwaj will deliver his talk on Indian planetary mission. And with this, I invite Dr. Bhardwaj for his talk. Over to you, sir.
Thank you. Very good afternoon. Namaskar. It's a privilege and honor for me to talk to the students of CSIR-JIGAYASA program under the series of Demystifying the Science. And I understand that the students who will be attending this seminar or attending this program today are going to listen to this talk on planetary science or planetary missions in India. I've tried to share my slides. Just confirm me whether you are able to see it. And if it is yes, then let me know. Is it coming online?
Not yet.
Not yet. Okay.
It's not visible.
Okay. Okay. Let me just try once more and do it. Okay. Let me know now.
Yes, it's there.
It's there.
But it's not visible as of now.
It should come.
Yeah, it has come now.
It has come. Great. Thank you. So, to all the students who are attending this webinar today, let me tell you that I'm going to take you to a journey to planetary missions and try to tell you how things have happened with respect to planetary exploration program in India. In particular, I'll be talking about the Mangalyaan, the Chandrayaan series of missions, as well as what India plans to do in the future. And as you must be seeing on the slide that I am from Physical Research Laboratory in Ahmedabad. This is one of the oldest laboratory of India, established in the year 1947 by Dr. Vikram Sarabhai. And hence, we are also 75 years old now, like our India's independence. And as we celebrate the Azadi Ka Amrit Mahotsav as a part of India's 75 years of independence, PRL is celebrating its Platinum Jubilee through a series of Vyakhyan series, which we call as PRL Ka Amrit Vyakhyan. And this series of Vyakhyanas is happening every Wednesday at 4 p.m. It is being delivered by distinguished scientists, technocrats, engineers, or people from the field of arts, literature, and business or law. So all of those who are interested to listen to such generic talks under the series of PRL Ka Amrit Vyakhyan, you are most welcome to tune to YouTube channel of PRL at 4 p.m. every Wednesday. Now, talking about PRL, which was established by Dr. Vikram Sarabhai, whose birth centenary we celebrated about 2 years back. And he established this PRL in the year 1947. And that is why PRL is called as the cradle of space science in India. And space science is a very broad subject as a part of science, maths, chemistry, and now including biology. But I will take you to a very particular area in the space science, which we call as planetary exploration. PRL has 4 campuses. If you see in the bottom left side, you will see the main campus of PRL, which is in Ahmedabad. We have another campus in Ahmedabad, which is called as Cottage Campus, which is about 5 kilometers from the main campus. Then we have in Udaipur Solar Observatory, which is in the middle of the Fateh Sagar Lake. So you can see here in the bottom middle, and that is a solar observatory for looking at the sun. And then we have an observatory in Mount Abu, which you are seeing on the bottom right, which is essentially for looking in the night sky to look at various exotic objects in the night sky, as well as solar system objects. And that is in the one of the topmost peaks in the Aravalli Hills called Guru Shikhar in Mount Abu. Talking about planetary exploration and PRL, I just told to you that Dr. Vikram Sarabhai established the PRL in the year 1947. He all started this in a small place which he called retreat. It's a part of his house. And then in 1948, it moved to a new location. But that was not a permanent location, it was a temporary location. And in 1951 was the first council meeting where the person standing here is none other than S.S. Bhatnagar himself. And 1951 itself, we started having first ozone measurement from Mount Abu. So PRL formally got established on 11th of November, and that is what we call as the foundation day of PRL. Actual building where I'm now sitting and giving you this webinar, the foundation stone was laid in the year 1952 by Sir C.V. Raman. Sir C.V. Raman, as you all know, is the Nobel laureate of India, and Dr. Sarabhai considered him as his real guru, and that's why he called his guru to do this foundation. And in 1954, we have the inauguration of this main building by then Prime Minister of India, Pandit Jawaharlal Nehru. And subsequently, the 8-story building came up in 70s. And in the bottom right, you may be seeing now how PRL looks like when it is celebrating its platinum jubilee. I mentioned to you about the second campus in Ahmedabad, which is called the Cottage Campus. This is about now 40 years old. It came into existence in 1980. And the two laboratories, which I just mentioned in the beginning, the infrared telescope at Mount Tabu and Udaipur Solar Observatory, both came in the year of 80s. The logo of PRL, you will see that on the right side, there is a circle with a cross. And this is the symbol of the Earth. And on the left side, you see another circle with a dot in the center. And that is the symbol of the Sun. And in addition to this, you are seeing a bigger circle, which is encircling both the circle. And if you translate this logo into the meaning, it translates as PRL research encompasses the Earth, the Sun, immersed in the fields and radiations, reaching from and to infinity, all that man's curiosity and intellect can reveal. So this is how the whole research of PRL is, that it talks about from infinity to infinity. Anant se Anant. Because if you look at the research field of PRL, it starts from end of universe to the core of the Earth. And if you classify these fields, they come under category of astronomy, astrophysics, solar physics, space and advanced science, atomic molecular optical physics, theoretical physics, geosciences, and planetary science. So essentially, all gamut of science which comes under the category of space science is pursued here in PRL in an internationally competitive manner. And then we have a student program, which is a very strong program. We take research fellows and postdoctoral fellows. About 150 of such students and postdoc fellows is there at PRL campus at any given point. Talking about how we all grew from the establishment 75 years back, research started in the area of cosmic rays and advanced sciences, because cosmic ray was the field of Dr. Sarabhai, and the first director of PRL, Ramanathan, was a well-known atmospheric scientist. So the research started in these two areas. But in 1962 itself, we have the formation of the INCOSPA and also introduction of radiophysics and theoretical physics in PRL. And in 69, we have the formation of ISRO. And in 70s, as PRL grew, we have the formation of Department of Space by government. And in PRL, we started with Earth and Planetary Science, infrared astronomy, and plasma physics. And the field of plasma physics started growing so much that we had to form another institute, which is now called Institute of Plasma Research, which came out from PRL. The field in the PRL got diversified further in 80s by including particle physics and solar physics. In 90s by including laser physics, quantum optics, nonlinear dynamics, computational physics, astrophysics, and cosmology. And in year of new millennium, we started into the area of planetary exploration and solar access. So different fields got introduced within PRL as the scenarios changed in the country. And if you look at what has been the contributions, just a few of the pictures, you must be well aware about this gentleman in the middle, Dr. APJ Abdul Kalam, the President of India, and who was actually a professor in PRL before he moved to Trivandrum, deep down south of India, for starting the rocketry program under the guidance of Dr. Sarabhai. And the first person, Professor U.R. Rao, who is an alumni of PRL, has done his PhD with Dr. Sarabhai, and subsequently was a professor before he moved to Bangalore to start the satellite program. And Dr. Kasui Rangan, all of you must be well aware because he has written the education policy of India now. He was a student in PRL and did his PhD and then was a professor here. And then he moved along with Professor Rao to Bangalore to contribute into the satellite program. And then both of these gentlemen, Professor U.R. Rao and Dr. Kasuri, had been the chairman of ISRO and secretary to space. There are many other photographs shown over here, and this is an exercise to you all to identify who these gentlemen are and where they are now and what have been their contributions. So let us move to our topic of Indian planetary missions. And in the bottom, you may be seeing the rocket on the left, on the right side bottom, PSLV, which is the Polar Satellite Launch Vehicle, which is one of the most efficient rocket of India and has been with a success rate of almost like 99.99%. And you are also seeing the Chandrayaan-2 mission as well as the Mangalyaan or the Mars orbit mission, about which I will tell you. So if you look at the space activities in India with respect to launching rockets, it started in the year 1963. Sarabhai ji sent Kalam Saab to Trivandrum at a place called Thumba, and the first rocket launch took place on 21st of November of the year 1963. But the experiments which are flown on these rockets are developed in PRL, in the Physical Research Laboratory. Subsequent to that, as Professor Rao moved to Bangalore, we started the satellite program, and we had the first Indian satellite, Aryabhatta, launched in 1975, which included instruments from astronomical and earth sciences. Subsequent to that, we have many other missions which are looking at X-ray astronomy or atmospheric sciences like SOS-C, SOS-C2, or Indian X-ray astronomy experiment, or the SOX on the GSAT missions. But the first planetary mission of India is the Chandrayaan-1 mission. Chandrayaan. Chandra means moon, Yaan means spacecraft. So it's all come from the Sanskrit word of Chandra and Yaan. And then Prime Minister of India, Atal Bihari Vajpayee, said we will call it as Chandrayaan-1. He said there should be a series of missions to moon, and that's why it was given number 1. We had the launch of Chandrayaan on 22nd of October 2008. We reached the moon after 16 days on 8th of November. And this mission carried 11 experiments, which we call as payloads. And 3 of them were actually being used for the first time for planetary probing through remote sensing. It was truly international character with 11 experiments on board, which you see here in this satellite, where you can see this one is much better over here. And I was directly involved with the instrument called SARA, which stands for Sub-K Atom Reflecting Analyzer, which has 2 sensors, SINA and SWIM, looking at, for the first time, neutral atoms at the surface of the moon, which you call ENAs, or energetic neutral atoms. We also had the Moon Impact Probe, which was sitting right at the top of this spacecraft called Chandrayaan, which was actually released after we reached the moon to land into the polar regions of the moon, exactly at the location where we are supposed to do. Now, you can see many other experiments mounted on different places of the spacecraft. They were all meant to do different science. And according to the science, they are situated at different locations of the spacecraft. Chandrayaan-1 has been the most successful mission of India. Why? Because it discovered water on the moon. Till that time, we were not knowing that water is present on the moon. We were all thinking moon is bone dry, there is no water on the moon. But it is the Chandrayaan-1 mission which actually discovered water on the moon, and it is found in form of hydroxyl or water molecules, not on the surface, but beneath the surface, we call subsurface, water ice, and in the lunar exosphere. That is very, very tenuous atmosphere on the moon, which we call as exosphere. This mission also validated the lunar magma hypothesis, essentially the process by which the moon came into existence, or the birth of the moon happened. It discovered many magnetospheres on the moon, essentially very small magnetospheres of few hundred kilometer size, the smallest in our solar system. In fact, it found out a great amount of information related to volcanic activity on the moon. geologically past timescales of 100 million years or so, which in turn suggests that there is a tectonic and volcanically active moon, and a couple of rallies which are actually formed by flow of lava, and we call it as lava tube, which can essentially be used by humans when the settlement starts. So this Chandrayaan mission science results have been published in more than 180 scientific publications, and many of them made the cover page of various science journals like Science and Geophysics Letters, because they were so high in terms of the science output. They came on the cover page of the journals. And this is the picture which I like very much, because this is an image of the Earth taken from the moon by the Chandrayaan-1 terrain mapping camera, and it happened on 22nd of July of the year 2009. And this date is very important because this was a date of solar eclipse, and we were interested to see the shadow of the moon falling on the Earth. So we oriented the whole Chandrayaan-1 mission to look at the Earth, to follow the shadow of the moon falling on the Earth. But unfortunately, as you must be seeing in this picture, Earth was full of clouds because it was July period, and that's why we could not get a very clear signature of the shadow, but we could still see the shadow falling on the cloud tops. This is how the surface of the moon looks like. Let me see if this movie really works here. If it is able to work, you'll be able to see it running, otherwise it will not work. But what I wanted to convey to you is that the surface of the moon is full of craters. There are craters of different dimensions and sizes, starting from centimeters to meters to kilometers to tens to hundreds to thousands of kilometers. And therefore, you will see craters inside craters inside craters, because any object which is falling on the surface of the moon will form craters because it doesn't have an atmosphere. Now let me talk about oops. My God, it's created some issue. Let me just come back to it, because just be there for a moment. I will just skip this presentation and share with you once more, because that movie is not at all working. So, okay, let me share this again. Okay, I hope you will be able to see it very soon on your screens. So, as I move from Chandrayaan-1 mission to the next mission of India, that is the Mangalyaan, or the Mars orbiter mission, and we say that Indian Mars, or in Hindi, Bhartiya Mummy Amma par pahunchi. This mission is also a very important mission, as well as important not only for India, for the world, because India became the first country in the world to have the successful insertion of an orbiter around the Mars in the first attempt. That is a rare feat India got to this Mangalyaan. In the bottom, you are seeing on the right side the launch vehicle, the PSLV-XL, which was used for launching this Mangalyaan or the MOM mission. And on the left side, you are seeing the whole spacecraft. And in the middle, you are seeing a big dish, which is basically a radio antenna, which is used for communication. Because when the spacecraft is in space, how do you communicate with the spacecraft? We communicate using radio waves. And that's why you need a big antenna. This is a 32-meter big dish or antenna, which is being used for communicating with the spacecraft. And we had the launch of this on 5th of November of the year 2013. And we arrived on the Mars after 10 months on September 24th, 2014. And since then, we have been orbiting Mars. It is now 7 years since our arrival on the Mars, and we are still working very well around Mars, though the planned lifetime of this mission was only 6 months. Okay, so this is again a rare technological feat, that a mission which was planned to live for about 6 months has lived more than 10 times its own life. It has completed already 7 years in orbit around Mars. Okay. This is how the geometry of the launch is, that we had the launch on 5th of November. We went around the Earth, then left Earth on 1st of December. Now remember, when we are leaving Earth, Mars is moving in an orbit around the Sun, Earth is moving in an orbit around the Sun, and we have to move in an orbit from Earth to Mars. And we have to do all precise calculations to see that when we reach Mars, Mars should be there, because everything is moving, right? And these all calculations has to be done precisely, otherwise you will miss the bus, essentially miss the moon. Oh, sorry, the Mars. Now, if you look at the experiments which have been flown on this mission, the MOM mission, they constitute a total mass of only 13 kg, whereas the total spacecraft mass is 1300 kg, 100 times more. Okay. So the experiments which is actually doing science on the Mars is only 1% of the mass of the whole spacecraft. And they consist of 5 instruments: Mars color camera, methane sensor for Mars, thermal infrared imaging spectrometer, Lyman alpha photometer, and Mars exospheric neutral composition analyzer, which in short is called MENCA. And this is an instrument called MENCA, where I am the PI, and when I was at Vikram Sarabhai Space Center. And they are all situated again on the different places on the spacecraft, which you see over here. MENCA is mounted looking up, whereas the cameras are sitting on one side looking on to one side of the spacecraft. And this is how we define the whole spacecraft by yaw, roll, and pitch. And in the space, we have to know where the spacecraft is by these kind of coordinate systems. This is the kind of picture we get from the Mangalyaan or the MOM mission. This is the whole disk image of the Mars. And if you look at in a different season, you will see the north on the top and the south on the bottom. They are all getting freeze because the Mars orbit is much more elliptical than the Earth orbit. I will repeat, the Mars orbit, as it goes around the Sun, is more elliptical than the orbit of the Earth. And because of which, the amount of sunlight which Mars receives varies a lot as it goes around the Sun. And 1 Martian year is roughly equal to 2 Earth years. So it takes, Earth can go around twice by the time the Mars take 1 circle around the Sun. I don't know whether you can notice something moving as a black dot on here on the top right side. This is actually Phobos. Phobos is a satellite of Mars, a very small satellite of few tens of kilometers in size. Actually, Mars has 2 satellites, Phobos and Deimos. Deimos is still smaller than Phobos. And this is an image which was captured by the Mars color camera when the Phobos was moving in front of Mars, and you can see the Mars movement, or Phobos movement in front of Mars. Mars also has features like valleys of Marinus, which you are not able to see here because it's all filled with all dust and clouds. But it is one of the biggest canyon in our solar system. It is much bigger than the Grand Canyon in US. And because of the clouds, you can see even the shadow of the clouds falling on the surface. Okay. So Mars season is very dramatic compared to that of Earth. And sometimes there are dust storms on the Mars which can engulf half of the hemisphere of the Mars. There have been fantastic results come out from the MENCA instrument, particularly talking about the evening time exosphere, which in fact made the sorriest of week for ISRO. And it suggested that the CO2 dominant atmosphere of Mars, because CO2 is the dominant gas on Mars, okay, in the lower atmosphere, it converts to oxygen dominant atmosphere. And it happens at somewhere around 250 to 60 kilometers above the surface of Mars, that a carbon dioxide dominant atmosphere goes to a oxygen dominant. And this is essentially happening because carbon dioxide is broken into carbon and oxygen being lighter starts dominating as you go up in that. Another result which we found was about the suprathermal argon, or we can say hot argon. And the significance of this result is that if you have slightly hotter argon in the exosphere of the Mars, exosphere is a region where molecules or atom doesn't collide. You know, the density of the air which you are breathing right now is about 10 to 20 particles per cc. But if you go to the exosphere of Mars, the densities would be somewhere around 10 power 7 or 8 particles per cc. So it's very tenuous atmosphere. It's a vacuum. Okay. And there, because atom and molecule doesn't collide, if any atom or molecule gets a little higher velocity, it will escape the planet. And that is why this result is actually changing our understanding of how the Mars lost its atmosphere. Because we have now seen that there are suprathermal argon atoms or atoms which have higher energy than the ambient. We have also seen a lot of orographical features, particularly clouds in the leeward side of the mountains. We have actually the highest mountain in our solar system on the Mars, which is called as Olympus Mons. And on the other side of the mountain, we see the cloud formation, which is quite similar to what happens on the planet Earth. This is how the demos look like, the other smaller satellite of Mars. And this is only the first time that we have seen how the demos looks like because of the much more elliptical orbit of the MOM around the Mars. After the success of the Mars in terms of its insertion in its orbit around the Mars on 24th of September 2014, one of my colleagues from US has sent me this photograph, and he says, "Your MOM has become so famous that it has come on the Coke diet." And 1 month later, on October 24th of the year 2014, Google actually celebrated the Mangalyaan by putting this doodle on the book. And Amul, the very famous brand of cheese, butter, and milk, they came out with this ISRO's cow Amul, a cheese buddy hai Mars, because they were all celebrating the success of the Indian Mars mission. And National Geographic came out with this cover page having the images taken by the Mars mission. And Government of India, realizing the technological feat which India achieved by becoming the first country in the world to have the successful insertion of an orbiter around the Mars in the first attempt, has brought the Mangalyaan on the back of the 2000 rupees. I hope all the kids must have noticed that we have the Mangalyaan on the back of the 2000 rupees note. Those who have not noticed it, today you can see it or demand from your parents to give you a 2000 rupees note. Now moving to the next mission, which is the Chandrayaan-2 mission, which is the second in the series. Chandrayaan-2 mission is much more complicated and complex than the Chandrayaan-1 mission because it not only had an orbiter like the Chandrayaan-1, but it also had a lander called Vikram lander and a rover. And the rover was sitting inside the lander, and the lander is supposed to land on the lunar surface. And you all know what happened on September 7th of the year 2019. Though we had everything going very well, after the launch, we went around the Earth, then we went into a lunar transfer trajectory, we went around Mars, got inserted, and then went into 100-kilometer circumpolar orbit. And then we went into the landing sequence of landing very close to the lunar poles. But about a kilometer above the landing site, we had not got a successful landing. But the orbiter is still in orbit around Moon. It is functioning very well and providing us a very good amount of data in terms of the quality. There are 8 experiments on board, and they are all looking at different features on the surface of the Moon, talking about three-dimensional maps, talking about elemental composition, looking at the water distribution, major elements forming the rocks, looking at the craters and other features, particularly beneath the surface, and looking at the tenuous exosphere and its plasma properties. So 8 experiments on board is looking at the Moon in a much different way than it has happened with the Chandrayaan-1 or with any other mission in the past. Okay, and we are getting excellent quality data from this. The experiments which are flown on the Chandrayaan-2 lander and rover are now going to go as Chandrayaan-3 mission. So India is now preparing for the Chandrayaan-3 mission, which will be exclusively a lander and rover mission, where we will be looking at the lunar surface using the rover. And the 2 experiments on the rover are LIPS and APXS. And both of them is actually looking at the elemental composition of the lunar surface. And one of these experiments called APXS is developed in PR, in physical laboratory here, whereas LIPS is developed in Bangalore. And then we have an instrument called Rambha, which is looking at the plasma properties near the landing site. And we have Chaste, which is basically a thermometer, to say in a layman language. And it is going to go inside the lunar surface to tell the temperature and how does the temperature changes on the surface as you go inside for the first 10 centimeter to 30 centimeter from the surface. And this is going to be done for the first time, okay? Because we are interested to see how the heat propagates inside the moon. And these all experiments are there on the Chandrayaan-3, which is to go to the moon next year. What we are getting from the Chandrayaan-2 orbiter, you can see this over here. We are getting fantastic images in terms of its distribution of features, looking at different locations using the three-dimensional or the three, what you call, four other enough orthogonal images and DEMS. DEMS means digital elevation maps, which in turn will tell you how high a surface is from the mean surface. And we have imaged the Sarabhai crater. Sarabhai ji has a crater on the surface of Mars named after him, which is called Sarabhai crater. And this is a crater on the near side of the moon, the side which you can see from Earth. And it is actually about 8 kilometers in diameter and about 1.7 kilometers deep. And it is situated at 24.7 degree north and 21 degree east. So if you have a small telescope, you can actually see a Sarabhai crater from the Earth. Okay. So this is an exercise to you, those who are really interested or are amateur astronomers, the kids, or you can go to planetarium, or you can go to any location where you get a small telescope. You can see this crater. Using the Chandrayaan imaging camera, we have got fantastic information about various craters. You can see here a big crater in the center, and on the walls of it, you can see small craters. So that is what I was telling you, that you will see craters inside craters, craters outside craters. Idhar bhi crater, udhar bhi crater, jahan dekho wahan crater hi crater. So everywhere you will see craters. And not only on the surface, you can get information beneath the surface that there are craters using the synthetic aperture radar. So there is a SAR instrument. It's a dual band SAR at L and S band, and that provides information about beneath the surface, not at the surface, but few meters beneath the surface. What are the processes happening to create the kind of conditions which we are seeing now? If you need to know that, you need SAR. Or you can see it in OHRC, which is basically high resolution camera, where you can see even small features of a few meters on the surface. And there is an instrument from the PRL, and that is Physical Cell Laboratory, called Solar X-ray Monitor, which is essentially monitoring the solar flux in X-rays falling on the moon surface. And why we need that? We need that because we need to know the elemental composition of the moon. That is coming out from the different instrument called CLASS. But to know that what amount of solar flux is actually falling on the surface, we need an instrument which is called XS. This instrument, which is developed in PRL, is the most sophisticated instrument ever flown for measuring the sun X-rays in 1 to 15 keV band. And it has the highest energy resolution and the cadence. That is, every 1 second of X-rays coming from the sun in 1 to 15. And for the first time, it has found that there are many sub-A class, or you can say microflares, happening on the surface of the sun, which has not been known so far. And this is actually changing our understanding not of the moon, but about the sun. Because we are seeing that there are many microflares happening on the sun, which we are not aware of. Okay? So that's what I was talking about, the major science results about microflares happening on the sun. And this is actually essential because if you look at the sun, you will find that the corona, which is the outermost layer of the sun, is hot, is extremely hot, like 1 million Kelvin, whereas the sun's temperature is only 600 Kelvin. So how is it possible that the temperature is rising as you're moving away from the sun? That means there is some other source of energy, and this could be microflares, which have been discovered by XS. And because of which, this was covered in different media and social media and newspaper channels and TV channels. And we have also looked at argon-40. Argon-40 is a radioactive element, and it comes out for the decay of the potassium-40. So how does this distribute on the surface of the moon and in the atmosphere? And what is its density as you move from day side to night side, particularly from equatorial region to the polar regions, because the Chandrayaan is a polar orbiting satellite. And this was the first time we have found out that distribution of argon across the moon. So what next? I talked about the Chandrayaan-1, I talked about the Mangalyaan or the MOM mission, I talked about Chandrayaan-2. Right now we are preparing for understanding the sun in more detail using the Aditya L1 mission, which is a solar mission. But of course, it is not going to go to the sun. It is going to a place called L1, and that's why it is called Aditya L1. Aditya means sun, and L1 is the location. So let me first tell you what is L1. Now, if you look at the sun, which is in the center here, the yellow circle, and Earth, which is in light blue over here, and the Earth goes around the sun. Okay. Now, L1 point is a point on the Sun-Earth line, just about 1% away from the Earth. Okay. So 99% away from the sun. And as the Earth goes around the sun, the L1 point also goes around. It is called a Lagrangian point. Lagrangian point 1. Okay. So the advantage of this is that you can continuously see the sun all the time, 24/7. Whereas if you are orbiting Earth, at some point of time, there you will be eclipsed, right? You will not be able to see the sun. Visible, ultraviolet, and in X-rays. Okay? So in the 3 wavelength band, hard X-rays, soft X-rays, ultraviolet, and visible. And look at the sun very close to the surface of the sun. Essentially, it is going to look at almost like 1.05 solar radiation. Okay? And it is not just looking at the radiation, it is also looking at the plasma which is coming out from the sun. Because sun is emitting not only electromagnetic radiation in entire electromagnetic spectrum, right from gamma rays to radio waves, but it also emits charged particles, which we call a solar wind, which is essentially largely protons coming out at a speed of about 400 km per second. It is supersonic, with a density of about 5 particles per cc. And it carries along with it the magnetic field of the sun with the intensity of about 5 nanotesla at L1 point. So we are interested to see what the plasma is coming towards the Earth from the sun. And we will be able to come to know because we are sitting right in the front of the Earth at L1 point. So we have instruments which is going to look at the charged particles at different energy range using instruments called PAPA, Aspects, and MAG. Whereas the instruments for radiation is visible emission line coronagraph, SOOT, SOLEX, and Helios. And essentially what it will give us, how the corona is getting heated up, how the acceleration of solar wind is happening, what are the processes like solar flares or CME is happening, how the dynamics of the sun and the coupling between the inner part and outer part of the sun. So all this is going to be coming out from this mission called Aditya L1 mission. Okay. So what we plan to do in the future? We have missions planned for going to Venus for the first time, and of course again to Mars. Now Venus, if you look compared to Mars, both these planets have carbon dioxide as their dominant gas in the atmosphere. Okay, so that means Mars is very similar to Venus, or Venus is very similar to Mars. But if you look at the atmospheric properties in terms of its temperature and pressure at the surface, Venus has a surface pressure about 100 times that of the Earth. The Earth's surface pressure is how much? 1 bar, right? Or 1000 millibar. At Venus, it is 100 times more than that of Earth. On the Mars, on the other hand, it is 100 times less than that of Earth. You understand? So what is happening? Venus has a very high surface pressure. Look at the temperature. It has a temperature of about 800 Kelvin. 800 Kelvin at the surface. Whereas Earth's surface temperature about 300 Kelvin, right? So Venus at the surface, if you look, is very hostile. It is absolutely not possible to live on the surface of the Venus. It is very hot, pressure is very high. Now, if you look at this image which you are seeing for the Venus, it is not of the surface, okay? It is of the clouds of the Venus. Because Venus is completely covered by sulfuric acid clouds. And it makes this Venus opaque in the visible. You cannot see the surface of the Venus in the visible light. Okay, so you need different electromagnetic radiation like microwave to see at the surface. And these clouds, which is at an altitude of somewhere around 40 to 60 kilometers above the surface, are also very interesting and very unique. Why they are unique? Because first of all, they are made of sulfuric acids. Number two, if you look at the densities and temperature at these clouds, it is somewhat very similar to that of the Earth. It's about 1 bar and about 300 Kelvin. So the conditions are much more benign and much more comfortable at the clouds heights, and that is why people are talking about now the life on Venus in clouds, not on the surface of Venus. Okay. Also, Venus is super rotating in terms of its clouds. In turn, it means Venus takes about 243 Earth days to rotate on its axis. Like Earth takes 24 hours, right, to spin on its axis. Venus takes 243 Earth days. So it will have 120 days day, 120 days night, right? If you live on the Venus, you have to work for 124 days, then sleep for 120 days. On Venus, the clouds are moving or rotating very fast. They complete one rotation or one revolution actually around the Venus in 4 days. You understand? So that means these clouds are moving at a very high speed. Okay, and that is make the Venus very interesting, and that's why you want to explore Venus in much more detail, because it's a very exotic planet, very different than Earth and Mars, and of course very different than any other planet. For the Mars, our idea is to explore it in much more detail than what we have been doing using the Mangalyaan. In particularly, we are interested to not only send an orbiter, but probably even a lander on the surface, because that is the way in which you can actually explore Mars in much more detail. Okay, and if you can do that, you'll be able to see it in much greater detail. Hello. Yes. I'll just call you later. Huh? So this mission for Mars and for Venus, of course, is going to be much more challenging for us, because we are going to send new instruments. We are going to explore Mars in much more detail in a newer way, and of course, for the first time, the Venus mission. And if you want to talk about the planets, let me tell you also that PRL works on looking at exoplanets. That is not only planet in our solar system, but outside our solar system. And we have recently discovered a sub-Saturn side exoplanets using our own telescope at Mount Tabu and using an indigenously developed instrument called PARAS. And this is made, the discovery was made about 3 years back of a star planet system, which is about 600 light years from Earth. And the planet rotating or revolutioning about the star completes its period in only 20 days. So it is moving very close to the star. And it is about 6 times the Earth radius and about 27 times the mass of the Earth. So this is a discovery, first discovery from India using our own telescope and our own instrument. And that made India one of the countries in the select group of countries. And that is why our Prime Minister Narendra Modi ji tweeted on 3rd of July of the year 2018, about 3 years back, that immensely proud of our scientists who created history by discovering a sub-Saturn-sized planet 600 light years away from the Earth. Congratulations to them. Discovery has put India among the select countries. So that's how the importance came, that Indians have also discovered exoplanet, and this you must be seeing, if you go to the ISRO website, you will see another exoplanet that is discovered now, and there's a press release to that. All this is happening using a telescope, which you see over here, 1.2 meter telescope. But now we are coming with another telescope, which is much bigger than the old one, which is a 2.5 meter telescope. And with this, our collecting area becoming 4.5 times, we will have a almost like an order of magnitude better capability than the existing telescope. And this is going to provide us much more opportunities in terms of looking at not only exoplanets, but also in terms of looking at other objects in our sky. So this is going to happen very soon. This is right now under construction, and probably by early next year, this will be under operation. So with this, I would like to end you and thank you all for listening patiently to my talk on Indian planetary missions. And if you have any questions, you are most welcome to ask. Thank you. Dhanyavad.
Thank you very much, sir, for this extremely informative and motivating talk. So I'm very sure that this talk would have helped many students who are connected with us understanding the Indian planetary missions, particularly Chandrayaan and the Mars orbital mission, which is very lucidly explained here. And those who don't know or have not noticed about this Mars orbital mission on a 2,000 rupees note, they will surely check today. So thank you once again. So we'll just see if we have any question from our viewers.
Yeah, so Shika, as you are checking the questions, let me ask one or two questions to Dr. Bhardwaj. Actually, although I'm also a student, I think when it comes to other areas, we are all students because you know how much ever we learn, there is so much more to learn. So really fascinating. So there is always this question of, we'll establish colonies on Mars, because I think that's one thing which is on top of everybody's mind. What do you think? Is it realistically, as a space scientist, do you think it's really possible in near future?
Absolutely yes. Absolutely yes. I have no doubt about it. Because if you look at the journey of humans, they have gone all over the earth now, right? Earlier we are all thinking what is there in the poles. We have reached the poles. We have reached the Himalayan top. We have reached moon much earlier itself. And very soon we are going to go to the moon also. Humans, I'm talking. And when it comes to colonization, most likely it is going to happen first for the moon and then for the Mars. Because moon, if you see, is much closer to Earth. The travel time between Earth and moon is hardly few days, you can say. It is something like people going on LTC. Now, so probably in the future people go on LTC to the moon. Okay, visit karne ke liye. And days are not far. It could be hardly 50 years or 100 years down the line, you will see such kind of things happening. Because the capability technologically and our understanding is increasing tremendously. And like right now, there's a commercialization of space with commercial visitors can go to space. Very soon, visitors will go to moon.
Yeah, no, that's a very interesting topic, and I think the younger generation may witness all these colonization. Right. They would have the opportunity. And the second question I had is, one, we are doing this space exploration and all that. There's a lot of benefits, but what is do we see this benefiting other science and technology? Because I see very fascinating instruments you're developing, right? So would these instruments be useful in other areas beyond space? Because research is very broad. So what would be the deeper impact of this kind of R&D into space?
I will tell you one or two simple spin-offs. We call spin-offs when we do technology development. The artificial limbs which is used for humans, this is a spin-off of the space technology. Because why I am telling this is, in space, we need very strong material, but very light material. Okay. And this is actually the requirement of our artificial limbs. That should be strong, but light, right?
Right.
And so there's a direct use of that. We develop certain, what you call technologies which have been used for artificial walls on heart for humans. Okay? So these are just two simple things I'm telling you, which is easily connectable to you. You can think about, this kind of a special material which you develop for space, which have been used for, what you call jackets for military, to shield the our army men from bullets. It becomes a extra coverage for them.
I think
He lost his voice. Yeah.
Even after these have not but
Yeah, yeah. Now it's back. Yeah, no, we lost you briefly.
some
We lost your voice.
I see. Okay. Oh, okay. I see. I thought
Now you're
that it
back.
was some extra sounds were coming in between. So there are many spin-offs which is coming, and of course the most important one is excitement to the kids, And I still remember when we had the Mangalyaan-1 launch, not just the launch, but also when we reached the moon, reached the Mars on 24th of September of 2014. That type of celebration which was made in the country, And that time I still remember our Prime Minister Modi ji was there in the control center. We were all there. We were all celebrating, and then he came down and he gave a fantastic speech. And he says, "Today, whole country should celebrate because it is the country's in terms of India putting the first orbiter, the first attempt around Mars." And there are plenty of photographs. I just showed you a few of them, but if you really see that time newspapers for next 2 days, it was all.
Yeah.
So it has excited the kids, it has excited the kids of the country to take science. So that is a very tangential benefit which you cannot explain in terms of money or in any.
No, very true. I think the closest this comes to is India winning a World Cup in cricket, I think.
Yes.
When it comes to Mangalyaan. Yeah, Shika, are there any questions? I think there are some, right?
I think Dr. Sridhar has a few questions to ask here.
Yeah, I have one more question.
Also from the viewers also we have, I think so.
So he can directly ask me, without
Yes, sir.
anybody
Yes, sir.
reaching.
Sir, my question is, first of all, thank you for your excellent presentation. It was an eye-opener for us, people with totally no space background. My only question is like, now our entire network, mobile, TV, everything is dependent on satellites. Now, moving ahead, will space become a strategic place, both for warfare as well as, space is going to be auctioned between people, between countries. How strategic is space area as well as, the control, dominance? And 10 years down the line, where do we, with all these missions, Mars mission and everything, where are we going, where are we heading, in fact? Can you throw some light, sir?
Okay, let me just tell you one thing first is that this kind of technology nobody shares. Each country has to develop their own. Okay, you can get some help, but the core technology is never shared. And that is why India has to do of its own. And that was the dream of Sarabhai ji, that India should be second to none in the world to have space technologies for the benefit of the human or mankind, in particularly the Indians. And with that aim only, he started the rocketry program and he started the satellite development program. He said India should develop their own rockets and should have their own satellite program. Now we have come a long way since that time. We now have heavy lift-off vehicles called PSLVs and GSLV, JSLV Mark III, which can lift a 6 ton to 8 ton. We are working on heavy lift-off vehicles and things like that. On the other side, we are working on making our satellites much more exotic or technologically savvy by putting different kind of sensors and which is benefiting the country, both in terms of resources as well as in terms of communication. And using that as a platform, we are doing the missions to different planets in our solar system. So one aspect is how do we benefit the mankind, that is Indians, both in terms of communication, in terms of resource management, in terms of meteorology, atmospheric science, cloud, cyclones, disaster management, and things like that. And strategically, how we use our satellites. Of course, I cannot tell you much more detail about that, but we do use that in many different ways. If you look at the world scenario, the things are changing pretty fast because the technology is being developed by different countries, because now we have much more spacefaring nations compared to 4 and 5 earlier. And newer players are coming. But the issue is that you have to have technology which is safe. And safer not only on the ground, but in the space, as I was mentioning. So we should have not just the technology to send our assets in space, but to safeguard our assets in space. Okay, so you should also have the technology to safeguard our assets, and that is what is being also worked about, including different missions where we do test various technologies, which is of course again a guarded secrets for many of the general public, because they are not of the nature to be told about. But we have to come up with the capabilities that we can safeguard our assets, whatever we have in space, and we work for that. So if you look at how India stands with respect to world, you can say that India is second, third, or fourth, or fifth, if you put 1, 2, 3, 4, 5, but number doesn't matter here. Okay, you should have your own capability, that matters. And if you have the capability, it doesn't matter whether you stand at number 1 or number 5 or number 2.
Thank you so much, sir. So we have many students connected, but no question as such. But I have one question, sir. We are talking about Mars landing or space landing. So how this is being taken up at space centers, like at PRL? Any biological features that need to be studied, and those things I just want to know here.
Okay, I think you are a biology student or what?
No, I am a sensing student. I want to know about sensing application.
Remote sensing, you mean?
Yeah, biomedical sensing, remote sensing.
Okay. See, you must have heard about Gaganyaan mission, which is basically a mission where we are planning to send humans into space, and the plan is to send two humans to space very soon, which is one part of the program where you see actually how biology is now coming into our space program, where once the moment humans goes to space, the biology straight away comes into picture. The second way of looking at it is that how do we look at life in other planets in our solar system, including Moon or Mars, and there we have to look for what signatures we look for. It is a question of what to look for rather than to look what. Means actually we have to define what could be the signature which we have to look for if we say life exists. Okay. Earlier, long back, I should say about 20 years down before, we are all talking about oxygen. And if oxygen is present, there is a large possibility of life. But now we know that on the planet Earth itself, there are species which don't need oxygen at all, and they are living. So that means oxygen is not a primary requirement for a life to exist. So only thing what is required is some source of energy, which could come from any possible ways. Even we are seeing iron living, there are what you call microbes which are living only on iron. So they derive their energy from iron only. So, or hot springs, temperatures are so high, but there are microbes which are living there. They are surviving at very high temperatures. So that means life can exist in extreme conditions also. And what I was talking about, this Venus being so hot at the surface and things like that, because 800 Kelvin is very high temperature. But we don't know that if some kind of life may have the capability to sustain this kind of high temperatures and still exist there on the surface of Venus. But as we understand now, it is a bit different. Now, coming to your question of what we are thinking about when we are putting a lander on the Mars and things like that, our interest is more in first exploration more in terms of the composition of the surface. Okay, because if we know much more detailed about the composition existing, we can actually utilize that. It is called in situ space utilization, or is ISRU, in situ space resource utilization. So that means you don't carry much stuff from Earth. You utilize what is available there and develop anything from that. The second thing is Mars is CO2 dominated. We need oxygen for breathing. That means you have to convert carbon dioxide to oxygen for us to survive. Because humans cannot simply adapt to breathe CO2 straight away. So we have to use CO2 to derive oxygen from it. So there are many challenges which will come when we undertake the mission to Mars, particularly because not just of survival, but of course, large travel time. It will take 6 months to 1 year for travel itself one way. So humans will be sitting in the spacecraft traveling for a very long time. But the way in which the technologies are growing, I am pretty sure still again that humans will be going to Mars and probably may have colonies in the Mars.
Yeah, I think there is one comment on Facebook, maybe on the CSIR one. I'll just read it out. Can we use nanomaterials based microstrip antenna for communication? And since sometimes there is noise or unwanted signal, or signal strength is less while communication, generally we use filter circuit to overcome this issue. So can we use microstrip antenna to overcome this issue, as it may also save power consumption too? So this is one.
Right. In fact, that is one area in which anything nano or micro is a savvy word for space exploration, because we want to make it as small as possible, as light as possible, and as durable as possible. It is not just making light and what you call less power consumption, but it should be durable. So strength in terms of both mechanical strength, but longevity. Because if the system fails, then you are nowhere. So you have to test and test and test and see that it has a very large lifetime. That is also a primary requirement which comes. And this micro steps for this communication issue is not with respect to using micro steps. Yes, one can use it, but it has to be directed. So why we use dish, when we do this communication, is that you cannot have a omni communication where you'll be losing a lot of power. You have to have directed, because if you look to Mars, it is so small in the sky, right? So if I use an antenna on the Earth which is omni, it is waste of power when we are radiating something and communicating with the Mars. So I have to have a very narrow beam of these radio signals to reach Mars, so that you get enough power on the Mars and start communicating with respect to Earth. So microstrip antennas in a different form can be used, but not just as a flat ones.
So I think there are no more questions. So thank you so much, sir, for connecting with us and for sparing your precious time with us. Thank you once again. Also, thank you, Dr. Geetawani, Sridhar ji, and Deepak ji, the entire team at CSIR headquarters, and also the entire Jigyasa Atal Tinkering Lab team for the webinar. And special thanks for students and all the audience for connecting with us today for the talk. So this webinar series has been restarted for the benefit of the society from science as well as for sensitizing the youth. So let us make this initiative a success by learning something new and also by creating awareness among other students around and inspiring them. So thank you once again, everyone, for joining with us. Namaskar.
Thank you.
Thank you very much. Namaskar.
Namaskar.
Thank you, sir.
Thank you.
Thank you very much.